The purpose of this video is to demonstrate how to use the eddy current slide rule calculator to determine the prime test frequency for testing Inconel tubing with a wall thickness of 50 mils or 0.050 inches thick. It only takes a couple of steps. First step, we have to match up 50 mil wall thickness with 1.6 standard depths of penetration. So to the right of my thumb is the standard depth of penetration scale. And if I move the hairline right here, that's one standard depth of penetration, but we want to move it over to 1.6. So bring it over to the right, there's 1.5, and here is 1.6 standard depth of penetration. Then I use the frequency slider. I'm using the blue side because that's the side that represents inches. And I just use that to line up the wall thickness, which is to the left of my thumb, to 50 mils. So you can see right under the red hairline, 50 mils lined up with 1.6 standard depths of penetration. The card is now set up to determine prime frequency for any of these materials having a wall thickness of 50 mils. All you have to do is move the red hairline to that material. Since we said we were going to do Inconel, if you look at the top here, it's got some materials listed, but if you know the conductivity or resistivity, you can just set it to that, which are these scales. These top two here for conductivity and that bottom one here for resistivity in microohm centimeters. But we just move the red hairline over to Inconel, which is right there. And then we just follow the red hairline down to the frequency slider. And you see the red hairline crosses over right there at about 390 kilohertz. So that's the prime frequency for Inconel having a wall thickness of 50 mils. If I want to see what the prime is for these other materials, I just move the slider. So if I go over to pure titanium, for example, you're looking at about 195 kilohertz there on the red hairline. If I go over to 9010 copper nickel, which is right here, we're looking at just about 80 kilohertz. And finally, we'll go over to pure aluminum, and that looks like it's about 11 kilohertz. So you can see this is a quick and easy tool to determine prime frequency for tubing or for plate. You can also determine F90 frequencies, optimum frequencies for conductivity testing, thickness testing, standard depth of penetration, and other things. If you go to that website on the screen there, eddycurrentcalculator.com, there are instructions on how to use this, and there's plenty of tutorials on there, as well as the formulas that the slide rule is based on. This is for sale on that website, also on eBay and Amazon, usually about 40 bucks. So this is a very handy tool to have in your eddy current toolbox, and I hope you enjoyed this video. Thanks.